All right, athletes. So today we're going to talk about probability distributions for discrete random variables. So let's break that all down. And again, this is going to be easy, but it all depends on you understanding when do we do this and in what situations, right? So again, everyone's going to be able to do this, but knowing when is always the most important part, right? It's like you having a bunch of tools. When do I use those tools? So check this out. So what I built for you, I have this on ChatGPT. Um, you guys will see this in the description, right? I had it build a nice, easy definition so you could kind of read over. But check the situation out, and then I'll break this down for us. All right, so we have 5 teenagers selected at random and let X, so this capital variable letter X here, it could be any letter, but we tend just to use X, be the number of them who have sent messages on their cell phone within the last 30 days. So notice, it could be the case that none of them sent cell phones, so that's why there's a 0 here, or out of the 5, maybe one of them, or out of the 5, maybe 2 of them sent, or out of the 5, maybe 3 of them sent messages, and so forth. All right. So because these are like counting numbers, these are discrete numbers, right? Think of it like you could count on your hand. So 0, 1, 2, 3, 4, 5. So these are discrete random variables. And the random variables, because we don't know how many are gonna say how many of them sent text messages out of the 5, right? And because it's changing, that's what makes it a variable. All right. So in this case, we have this setup. So this setup is called a probability distribution because it tells us, hey, what's the chances that exactly 5 of them sent text messages? So here you can see it's 22.6% or the probability of 0.226, right? So here they're going to ask us these questions and start to dive into the heart of what we're talking about. So when it says P of 4, make sure you understand what that means. Don't just get an answer. Again, make sure you engage with the material and you learn how to speak the language, because in the jobs that you're going to have in the future, you're always going to need to speak their language, right? And so here this means P of 4. So what this tells us is that what's the probability that exactly 4 of them sent text messages? So we can see the probability of 4 of being 0.226. That easy using this table. Later on, we'll figure out, wait, how did they get this table? That's coming soon, right? Right now, we're just learning how to be good users of the table. What's the probability of more than 3? So remember, give me more than $3. Would you give me $3? No, I want more than $3. So we're looking at the probability of 4 plus the probability of 5. So you could see when it says more than 3, that's why we add up those two probabilities and we get 0.284, 28.4%. All right, I know they're not asking for percentages, but again, I want you to have that mindset. Awesome. All right. What's the probability that 4 or more of the teenagers sent messages, text messages, right? 4 or more. So now we're also including that 4. So this says the same exact thing as this right here, just using different language. So again, one of our quiz questions later on is going to say, hey, use 2 phrases that mean exactly the same thing. So here's a perfect example of that. So 4 or more than 3. So notice this one, more than 3 is strictly more than 3, but this one says more than 4, 4 or more, excuse me. So you're also including 4. All right, so make sure you're writing down all those notes because again, this is going to be very easy to forget if you're not writing these notes. And last but not least, find the probability that fewer than 3 of the teenagers sent text messages. So when we say fewer than 3, we're not including 3, right? So we could have probability of 0 sending messages, probability of 1 sending messages, plus probability of 2 sending messages. So that's why we add up those 3 probabilities right there. And these numbers, again, always come from your table here. So probability of 0, 0.016, probability of 1, 0.098, probability of 2, 0.269. All right. And again, something you might be thinking about, what's the probability you subscribe to this channel and share it with a friend or not? Because again, what I love is people saying, hey, your videos are being shown in my brother's or my sister's classroom, because math isn't an easy thing to teach, right? So again, I want people to see these videos so they could use them for their own classroom, or if they're learning the topic and their teacher's having trouble showing them, I want people to see this. So do me a favor, subscribe, like, so more people could see the content. All right, so there's number one. Let's go to number two. And again, I'm hitting this explanation button because people are using this, but they're not really understanding. They're just kind of going through the motions and kind of copying what the examples do, but they have no idea of what they're doing. So again, I want to walk you through what these explanations are really saying. All right. Another thing they're going to ask you to do after you have a probability distribution, just like this, they're going to say, hey, what's the mean and the standard deviation of this distribution? All right. So what you're going to be doing is you're going to be your x values, your random variables, your variables, excuse me, you're going to be putting them in L1. It doesn't really matter what list you put them in, as long as you know where they're located. So in your calculator, remember, go to stat, edit, and then this goes in L1. The probabilities are going to go in L2. So if I show you real fast, let me pull up my calculator. Let's see if I have it locked and loaded. Yeah. So let's pretend in edit, I have, oh, there's a commercial. Give it a second. So if you're using the free version, they throw commercials at you. All right, that's not my commercial. So notice in L1, I could have 0, 1, 2, 3, 4, blah, blah, blah. And here, let me clear this list real fast, would be the probabilities. So I could have like 0.1 and 0.2 and 0.3. Again, I'm just making these values up. And then point whatever, 0.05 and 0.02. I just made those up. But once you have them in the list, then you hit stat, calc, and you're gonna do one var stat. And in your list, L is L1, and then the frequency list, that's where you're gonna put L2, right? So that's if you're using, well, how you do it on the calculator, all right? And so let's go back to our problem here. All right, so that's what they're doing here. All right, and once they go to calc one var stat, and then L1 comma L2, just like I showed you, what your calculator is going to do is it's going to give you your X bar. So remember, your X bar is your sample mean or population mean. And so there it is, 2.861. So there's your mean, 2.861. And the standard deviation is 1 point. If you're wondering why they got 1.1, because you're rounding, because I think they wanted one decimal place. So since that's a 0 and then a 9 after the 0, we round that 0 up to 1. So remember, if this next number is 5 or greater, you round up. All right, and that's all they want for question number 2 here. All right, so that's how you find the mean and standard deviation of a probability distribution. All right, and so here, this one's a little different. So here's a shortcut I'm about to give you. All right, they're gonna do it a little different. So if you hit this explanation, they're not gonna give you all these details, but again, that's why I'm here. All right, so notice in this problem, what they do is they do not give you the probability. So what you're going to have to do is you're going to have to create the probability distribution. So how do you do that? All right, so here is the shortcut. So let's use those numbers 0 through 5. And let me pull up my calculator again. So we're going to go, let me clear all this. So stat, edit, 0 through 5. And then this time they give us frequencies. All right. And let me go back real fast. Do let me do split screen real fast for you. All right, let me get that other screen going. We'll do split screen so I don't have to jump back and forth. All right, so let's share. All right, let's shrink myself. Cool. So we have 19. We have 432. We have 265. We got 67. We got 16. And then we got 11. All right. So check this out. This last list, let me clear it. We don't need that information anymore. All right. Notice they don't give me the probability. So because they don't give me the probability, here's what you do. So at the top, make sure L3 or whatever is highlighted, hit enter. All right. So you click it, hit enter, and what's going to happen is down here, you're going to see L3 equals. It's probably hard to see on my screen, especially if you're using a phone. But here, you're going to put a formula. So what we're going to do is we're going to take all these numbers and list two. So I'm going to hit second, list two, and we're going to divide all of those by the total. So here, you can see your n value, right? The total number of people, which were 810, as they already told us. We're going to divide each one of those by 810, and voila. Now you have the probability distribution. So look what they did. So they took 19, divided it by 810. They took 432 divided by 810. They took 265 divided by 810. So instead of you doing every single one individually, like 19 divided by 810, right? They did all that work for you. So that saves you a whole bunch of time. So clear this. All right. So make sure you write that down so you could utilize that, because that's going to save you a whole bunch of time. All right. So now what I really want, let's see what they're asking now. Construct a probability distribution. So there it is. There's your probability distribution. So let's kind of see, look at their numbers, 0.023, 0.023, 0.533, 0.533. And notice they want you to round to, how many decimal places? Round to, it says, it'll say up here somewhere. It doesn't tell us how many decimal places to round to. So in your program, you should get away with rounding to however many decimal places. Here, 0.327, 0.327, 0.083 if we round, 0.083, and then 0.020, boom, and so forth. All right. So now that you have this, then we just start answering the same questions that we did before. What's the probability that a person would wait for 1 day? So 1 day, we just go here, one, boom, 0.533. What's the probability that the person would wait more than 4 days? So more than 4 days, that would be 5 days. That's just another way of saying the person would wait 5 days. So 0.014, bam, there it is. All right. So again, when you understand this, it's not so hard. All right. So again, make sure you're asking questions in class and taking detailed notes of this video. So let's move on. So let's look at question 4, see what's going on in question 4. It's going to ask you the same thing, but this time it's going to want the mean and standard deviation. All right, so this one, question 4, wants the mean and standard deviation. So notice, is that all it's asking? Yeah. So again, they set up just like I did, a probability distribution, and then you do L1 and L2. All right, so not so bad. And then we have number 6 here. This one's talking about, looking at business projections. So let's read this together. All right, so excuse the printer in the background. So an investor is considering an investment in a startup company. She estimates that she has a probability of 0.4, 40%, that this company is going to have a $14,600 loss. The probability of 0.20 that it's going to have an $8,500 profit. A probability of 0.11 of a $36,000 profit. Probability of 0.29 of breaking even. That means a profit 0. So what is the expected value? What would you advise the investor to make? Let's see. Would you, advise the investor to make the investment? All right. So first things first, let's use all this information to create our table here. So notice, because that first one's talking about a loss, that's negative dollars, right? So we have negative $14,600. And then right underneath it is the probability of that happening. Then there's a 20% chance you're going to make this. There's 11% chance you're going to make this. There's a 29% chance you're going to break even. So basically, we take all that information and we structure it nicely on a table. All right. Now that you have these random variables and their probabilities, all we do is we multiply this times this, this times this, this times this, this times this, and we add them. So that's how we find the mean, which is the expected value. So this is what we expect to happen. All right. So we get negative 180. So the expected value of the profit is we expect to lose $180. All right. So the investor should not make the investment because it's not an investment, right? If you're losing that money. All right. So that's how we're going to break that up. Number 7 is very similar, except now they're talking about insurance policy for this 81-year-old woman. All right, so this woman pays a premium of $4,100. If she dies within 1 year, the company is going to pay this amount of money, $74,000, to her beneficiary. So according to the U.S. Centers of Disease Control and Prevention, the probability that this 81-year-old woman will be alive 1 year later is not around 95%. Right, so let X be the profit made by the insurance company. All right, so here we got to be careful. So this right here is represents what? Because I noticed people have been emailing me and they're like, where is this number coming from, this negative 69,900? Well, check this out. Here we're talking about, this represents how much the insurance company would make. That's what X represents. So always know what X represents. So X represents profit. So if the insurance company pays out 74,000, all right, that's not profit. So you're like, well, why is that 74,000 not right here? Well, notice this person had a premium, how much they paid. So what you do is you take that 4,100 and that's what they made, but then you subtract how much you're going to pay them. Right? So 4,100 minus 74,000 gives us this number right here of 69,900. So that's why it's negative, because this is a payout. So it's not a profit, right? Well, what's the chance of that happening? Well, we know the chance that this person is going to be alive is 0.9457. So the chance of this person dying would be the complement, which is 1 minus this. So if you do 1 minus 0.9457, that's where this number comes from, right? So that's the probability that she dies. So this, the probability that she dies times how much they would have to pay out, right? After they get their money, all right? This right here represents how much money is gained. Well, what's a chance that, they're going to get this money, get to keep it, basically this woman not dying? Well, there's a really strong chance of her not dying, right? So once again, we multiply these two, and or you could do L1, L2, and then 1 var stats, but it's just easy to multiply, and add up those 2 results as you see down here, and you get 81.80. So the expected gain for this insurance company is $81.80. And so what happens is these insurance companies, once they do these calculations, right, they're doing it for so many people that they're making huge profit margins, so that when someone does die, right, they have way over enough profit so they could pay out to these beneficiaries. All right, so hopefully this makes sense, folks. And then number 5, just to make sure it's nothing different, it's the same thing when we're looking at this is a lottery question. And again, if you're wondering why isn't this number 700 when you're constructing your probability distribution, the reason it's not 700 is because remember you already paid $1 for that lottery ticket. So because they already received $1, when they pay out the 700, right? They already got that dollar, so they're really paying out $6.99 because that $1 was yours that you started with. And then this is how much they would use. But again, make sure you know what the X represents. In this case, X represents, let's read it, which profit? Let X represent the profit in dollars. So it says, what is expected value? What is expected value of your profit? So if you're paying the $1, that's why it's negative. How much money would you get? You wouldn't get 700, you would get 6.99 because you already paid that $1. So that's where that number comes from. There is almost 100% chance you're going to lose, right? 0.999, but there's that 0.1% chance that you're going to win. So again, multiply these two, and add your results. And so your expected loss is that 30 cents. All right, mathletes, hope this makes sense. Hope you're having a great weekend. I'll talk to you soon. Peace out.